This is our final project for our Solidworks car jack assembly for the class of DFT170 Engineering Graphics by Eli Hayes, Julius McLemore, and Aiden Tarble, with instructor Dr. Hans Chapman for the semester of spring 2025.
These are our reference images. Figure 1 shows the model that we were given to represent. Figure 2 is our final assembly of this model. Brainstorming and designing. Figure 3 shows the sketch of the side panels. Figure 4 shows the sketch of the piston, the front, top, and right views. Figure 5 shows our sketch of the lift. Figure 6 shows the linkage arm for the connection of the mechanism.
Here we have our part models that we made in SolidWorks. Figure 7 shows the frame of the car jack. We started with a sketch with holes in it that we extruded, that way we could put fasteners in later. Then for the handles, we used a reference plane and dragged a circle along an arch path. Then we mirrored it for symmetry, and figure 8 is just a simple revolve. These two, figure 9 and 10, are both part of the handle, and they were made pretty similarly. We revolved a rectangle to make the cylinder part. Then we drew a sketch at the base and extruded that. And then we chamfered the edges and extrude cut holes for fasteners. Figure 11 shows the piston on the inside of the mechanism. We drew a circle and extruded it. Then, for the right side, we drew a rectangle and extrude cut. And on the left side, we drew a sketch, mirrored it, and then extruded it. Afterwards, we filleted it and we added holes with the extrude cut for basic fasteners. Here we have the saddle. This was made pretty similarly, but we had a circle, we extruded that, and then at the base of that we had rectangles which we extruded, and on the sides we extruded circles for fasteners. Here we have the linkage arms. Both of them are pretty similar, except figure 13 shows two linkage arms that were connected using the extrude and fillet tools. Figure 14 has a basic linkage arm, except on the back end there's an extruded circle to merge the gap between the parts and to give extra room for the mechanism to move. Here we have two basic fasteners. Fastener A was made by extruding a circle and then extruding a hexagon on top of that. Fastener B was made by revolving a mushroom shape and then extrude cutting an X on the top. If we were making a real assembly, we would have had better fasteners with threads, but this assembly is more to just show the lifting mechanism. Here we have our assembly drawing document. We have our front, top, and right side views, as well as our isometric view in the top right corner. We have section A that shows the inner mechanism by having a cut right down the center. We have detail view B that shows the detail view of the piston in isometric view. We have auxiliary view C that shows the angle of the slope of the frame.
Here you got the exploded view, and it shows each individual part and how they go together. Our simulation of the assembly made out of alloy steel showed by putting 5 pounds of force on the lift, it deformed the linkage arms. Figure 20 shows the previously modeled arms for the mechanism, and the picture below it shows the reconstructed linkage arms. This animation shows that by pulling the handle, it forces the piston forward, thus lifting the saddle up.
Concluding remarks consist of through brainstorming and communicating effectively, it led to different ideas and solutions to create our final project. Our group sketched out all of the parts for our assembly to plan out our model using pencils, rulers, arc templates, and protractors.
We worked together to model the different parts with our use of the extrude, mirror, revolve, and reference geometry features. Due to time constraints, we were unable to make the handle mechanism as good as it could have been, but with enough time, we would have redesigned the mechanism using things like a spring and a U-bracket.
Given a real-world situation, it would be much harder to create and design a standard car jack. Our simulation showed we would need stronger arms. By making the arms bigger, it would give more support for a heavy weight on the lift. Our drawing document is used for accurately showing the different orthogonal views, also including detail, section, and auxiliary views.